Hello, AI enthusiasts! Welcome back to the AI Foundation Learning, where we make complex AI concepts easy to understand. Today, we're diving into one of the fundamental topics in machine learning, classification algorithms. Whether you're a beginner, an AI enthusiast, or a professional, this video will help you grasp the basics and applications of classification algorithms. So, let's get started. Before we dive into classification algorithms, let's take a step back and understand some foundational concepts in machine learning. Machine learning, often abbreviated as ML, is a subset of artificial intelligence. It involves training algorithms to learn from data and make predictions or decisions without being explicitly programmed to perform the task. Think of it as teaching a computer to learn from experience, much like how humans do. At its core, machine learning can be broadly categorized into three types: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning, which includes classification, involves training the model on labeled data where the correct output is known. Unsupervised learning, on the other hand, deals with unlabeled data, and the algorithm tries to find hidden patterns or intrinsic structures within the data. Reinforcement learning is all about training models to make a sequence of decisions by rewarding them for good decisions and penalizing them for bad ones. Now, within supervised learning, classification plays a crucial role. It's all about sorting data into categories based on input features. Now, let's dive deeper into supervised learning and explore classification algorithms in more detail. Classification is a type of supervised learning where the goal is to predict the category or class of a given input based on prior observations. It's like teaching a machine to recognize patterns and make decisions based on those patterns. From diagnosing diseases to filtering spam emails, classification algorithms are everywhere. To understand classification better, let's break it down with an interesting example. Imagine you're a botanist studying a new species of flowers. You have data about different flowers, including their petal length, petal width, and other features. You want to classify each flower into one of three species: setosa, versicolor, and virginica. Based on the patterns in your data, a classification algorithm can help you identify the species of a new flower. Now that we have a basic understanding, let's delve into some of the most popular classification algorithms, starting with logistic regression. Logistic regression is one of the simplest and most widely used classification algorithms. Despite its name, it's actually a classification algorithm, not a regression one. Logistic regression works by using a logistic function to model the probability of a binary outcome. For example, predicting whether a student will pass or fail an exam based on their study hours. The output is a probability value between 0 and 1, which is then mapped to a class label, like pass or fail. Next, let's look at KNearest Neighbors. KNearest Neighbors, KNN, is a simple, instance-based learning algorithm. It classifies a data point based on how its neighbors are classified. Imagine you have a data set of fruits categorized as apples or oranges based on their features like color and size. When a new fruit comes in, KNN looks at the K nearest fruits in the data set. If most of these neighbors are apples, it classifies the new fruit as an apple. Moving on, let's discuss decision trees. Decision trees are intuitive and easy to interpret. They work by splitting the data into subsets based on the value of input features. For instance, consider a decision tree that predicts whether someone will buy a particular product. The tree might first split based on age, then on income level, and so on. Each node represents a decision point, and the branches represent the outcomes of these decisions. Next up, random forests. Random forests are an ensemble method that combines multiple decision trees to improve classification accuracy and control over fitting. Think of a random forest as a collection of individual decision trees. Each tree is built on a random subset of the data and features. The final classification is determined by averaging the predictions of all the trees, which usually results in more robust and accurate predictions. Finally, let's talk about support vector machines. Support vector machines, SVM, are powerful for both linear and nonlinear classification tasks. They work by finding the hyperplane that best separates the classes in the feature space. Imagine plotting data points in a two-dimensional space, where each point belongs to one of two classes. SVM finds the line or hyperplane in higher dimensions that maximizes the margin between the two classes, ensuring the best separation. These are just a few of the many classification algorithms out there. Each has its strengths and weaknesses, and choosing the right one depends on the specific problem and data set. Classification algorithms are used in various applications. 1. In healthcare, predicting diseases based on patient data. 2. In finance, detecting fraudulent transactions. 3. In marketing, segmenting customers for targeted advertising. 4. In technology, recognizing objects in images and videos. Before we wrap up, let's quickly discuss some key considerations when working with classification algorithms. 1. Data quality. The quality of your data greatly impacts the performance of your classification model. 2. Feature selection. Choosing the right features is crucial for model accuracy. 3. Model evaluation. Use metrics like accuracy, precision, recall, and F1 score to evaluate your model's performance. 4. Overfitting and underfitting. Balance between model complexity and generalization to avoid overfitting or underfitting. That's it for today's exploration of classification algorithms in machine learning. I hope you found this video insightful and now have a better understanding of how these algorithms work and where they can be applied. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more AI-related content. Thanks for watching, and see you in the next video.